lot of you guys out there that are trying to adapt RX7 engines into the RX8 for all the right reasons, because the RX8 engine has proven to be the weak point of a very fine car, and it doesn't make any power, and it's prone to failures because of the side exhaust port, as we see here. Big problem is that when most people do a swap of this nature, you end up having to adapt a great deal of things from the third generation RX7 or a previous RX7 block to the RX8, doing away with all of the neat features of the RX8, like the electric powered steering, the electronic oil metering pump, the pulley arrangement, the triggering arrangement for the computer, all of the air conditioner for one thing, which is a bolt-on proprietary piece that goes actually on the front cover of the RX8, right in this cavity. So there's a lot of adaptations that have to be done, and in the end you end up with a car that's neither one nor the other, and you end up giving away a lot of the features of the RX8. So, having given it a great deal of thought and a proper integration of bringing a hybrid engine together that will have both the great features of the third generation RX7 block with the RX8, all the proprietary features of the RX8. We've studied all the options and have come up with what we think is the best development at this point that anybody has actually come up with. The RX8 front side housing, the iron, is longer than the RX7 third generation block, and for that matter, any one of the previous RX7 front covers. The reason being is that they had to extend it in order to make a provision for the side exhaust port, which is the primary reasons why this engine fails so much. They run so hot, they end up burning and frying out the compression and water seals of the engine. And also, even though from factory the port timing on these engines have been pushed to the maximum, the poor design of the rotor combustion chamber doesn't lend itself, plus the high compression doesn't lend itself to turbocharging. Hence the reason why none of the modifications that people try to do to the RX8 engine end up yielding anything that's either reliable or producing any kind of power. So the approach that we have taken is basically re-engineering the front of the engine in order to adapt the RX8 front cover to the RX7 front side housing. The big deal here is that the RX8 side housing, like I said, is longer. It's physically longer, and the reason is it has to make room for the exhaust. The counterweight is designed in such a way that the bevel is on the back side in order to give clearance to the side exhaust port. Since we don't have that issue on the RX7 engine, when you try to put an RX8 front cover on the RX7 engine front plate, front iron, let's just call it a block from now on, what ends up happening is that the RX8 counterweight ends up hitting the inside of the front cover because there's no provision for the mass that it needs in order to balance the rotors. So the approach that we've taken to re-engineering the front of the engine so that everything works is basically redesign and come up with a proprietary front counterweight that will fit, that will balance the internals of the RX7 engine block, meaning that you could use any compression ratio rotors available, not including the RX8 rotor, and redesigning a counterweight that moves the geometry of the weight in the opposite direction, since we don't have the exhaust port to deal with, and we basically bring the counterweight further back into the block. The way that we do that is by redesigning a very, very old, early 13B, like a 6-port engine, or even better, an old 12A counterweight. This is where the technology lies. It's in the design of the backside of the counterweight. The RX8 counterweight has the bevel on the backside. This is required to make room for the exhaust port. I've said that already 3 times. In not having the exhaust port here, this cavity is open, we take an old style counterweight which requires the mass to balance the heavy rotors, or the heavier line of rotors, which could be lightened depending on the state of tune you want to take the arrangement, the engine. Put the weight on the backside and bevel the front instead of the rear. In doing so, it allows us to put the counterweight deep inside the engine block, just like it would come on a 3rd generation or a 2nd generation RX-7 engine, for that matter, any year RX-7 engine, and giving us the room so that the counterweight doesn't hit anything inside the front cover. In doing so, it allows us to put the front cover of the RX-8 into the RX-7 engine block. In doing so, we can hang the air conditioner exactly where it goes. We can use the triggering system of the RX-8 with the RX-8 computer. We can use the RX-8 electronic oil metering system and not give up the electric power steering system. When we do this setup, obviously we need to balance the engine, so we have to start out with a very heavy counterweight which has the mass in the back instead of in the front. Once we modify the counterweight, we have to give it the correct shape so that it doesn't hit any of the obstructions within the front cover of the RX-8 engine, thus allowing us to do the whole front stack with the RX-8 front oil pump, which is one of the best oil pumps to date. And that allows us to hang the air conditioner where it goes, use the triggering system, use the oil metering pump, use the RX-8 water pump and pulley system. In essence, the RX-8 computer does not know that it is actually physically driving an RX-7 engine, especially the the 2004 and forward 6-port blocks, which are 4 injectors. The old 6 injectors, you actually had to trick the computer into thinking that it was only driving 4 injectors instead of 6. You could also, if you're building a very high horsepower engine, obviously you want to go with 6 injectors, but if you want to keep it simple and you want to keep it in the range where you don't end up destroying the torque capacity or exceeding the torque capacity of the RX8 transmission, which is about 340 horsepower, not much more over that. You can very easily double the power of the car by putting a 3rd generation or a 2nd generation RX-7 engine block with the RX-8 front cover with a custom counterweight balanced to the rotating mass of the rotating assembly that you're using, whether it's low compression, mid compression, S4, S5, early 13B, whatever. I'm not mentioning RX8 because the RX8 rotor doesn't lend itself to doing anything like this, besides the fact that it just has a very poor combustion characteristic and doesn't allow for any boost. So in doing so, we have basically overcome all of the engineering redesigns of having to retrofit an old style engine block into the RX8 architecture of the engine. With current day computers that are available as plug and play units for the RX8, in particular the electronic, which is a full standalone, fully mappable, plug and play computer that piggybacks onto the factory computer. Every feature in the dash will work, every idiot light in the dash will work, the gauges will work, everything will work exactly as if the car had an RX8 engine, except it will have an RX7 engine that can be boosted to the stratosphere, depending on what compression ratio rotors you choose to use. The shortcomings of the RX8 engines, it really can't be built to any level of performance, whereas the RX7 third generation engine in particular, we all know what we can do with it. In doing so, we have basically overcome all of the shortcomings, and the stock wiring harness is the same. The power wiring harness goes from the fuel rails directly to the computer that is housed in the front over here, so there's absolutely a minimal amount of electrical modifications. Actually, there are no electrical modifications to be done. Everything will work. All of the interior lights will work, the gauges will work, the fly-by-wire throttle will also work.
Cruise control?
Pardon me?
Cruise control?
Cruise control will also work. Everything works.
What about the intake and exhaust?
Well, thank you for bringing it up. This brings it to another major benefit. By mounting the third generation engine block, which mounts on the back steel plate, we can go directly to the rear cross member of the RX8, getting rid of those giant engine mounts that it has in the middle of the engine block that actually cover the exhaust manifold. When you remove the exhaust manifold of the RX8 and you remove the engine mounts of the RX8 and you mount the engine in the back, as in the third generation RX7, you have room to put a turbo that big inside that engine compartment. It is unreal the amount of room that is left over once you remove those factory RX8 engine mounts. And what was the second question?
The intake.
The intake system? Okay, that is the one piece that does require an aftermarket intake. The third generation intake system was designed from factory to kind of come back a little bit, and in doing so it will actually hit the firewall of the car, but we found a way around that. There's a company called Excessive Engineering, there's another company called Underground Engineering that make a very clean, very beautiful intake manifold that is very high flowing. Is what a lot of the drag racing guys use, and the high, the guys that are making 600-700 horsepower out of the third generation RX7 motor, which it comes straight up instead of going forward. Not only that, but the intake manifold has a provision for 4 injectors, and you also have 2 injectors in the center intermediate housings, which are your primary injectors. So whether you have an early RX8 which uses 6 injectors or a late RX8 which uses 4 injectors, either way we can accommodate whatever the computer of the year of the car came with, and again, the ECU will not know that it's driving a high-powered third generation FD engine block. I have a manifold here, but it's actually bolted onto a race car. If you want to stop the tape and we can go over, we'll show it to you. This is this lower manifold here is the manifold that's made by Excessive Engineering. As you can see, it comes straight up, and the port runners are substantially healthier than the stock third generation lower intake manifold. It also has provision for 4 injectors, 1 on each runner, plus the 2 injectors that are on your intermediate primary center housing. So again, you can run 6 or you can run 4. Makes no difference, and you use the stock wiring harness directly to the ECU. You piggyback it with an electronic plug-and-play ECU for the RX8, map it to whatever power and boost you want to run, and we've done it all for you. We intend to provide, we're going to build a couple of cars to prove the concept, and at that point we're going to start selling turnkey cars for customers that want to do this. There's a lot of you guys out there that have been wanting to do this and kind of going about it by taking advice from different people that haven't really sat down and figured out and engineered the proper way to integrate this system together. We also intend to sell a kit where we will provide the front counterweight, balance for the rotor weight that you choose to use if you want to use a JDM engine, or you can send us the whole engine and we'll balance the whole engine for you if you really look at together, you know, real high power. But being that, you know, Mazda has specific counterweights for a specific letter of rotors, we can make you a counterweight that will be in balance up to the range of about 8,600 RPM, just like a street car. If you want to build a race car and you're going to be spinning this thing, you know, 9, 10, 11,000 RPM, then it is essential, whether it's an integration like the one that we're talking about, or a, you know, a racing engine, or an FD engine, or an FC engine, it must be balanced anyway. So at that point, it doesn't really matter what year rotor you use, what compression you use, because you are building a custom-built motor. But for the guy that just wants to buy a JDM third generation engine block and buy our kit, which will basically be a front and rear counterweight, an engine mount system, an already programmed computer, and a RX8 front cover, because you'll have an FD engine or an FC engine. You can do that too and basically put it together yourself at home.
What about the throttle system? Are you running some special throttle assembly on these engines?
No, man, the throttle system is just absolutely how beautiful the way it's going to work. Just like the RX7 FD has a throttle body that controls the primary and the secondary side of the engine, and this is a third generation throttle body, and as you can see, the primary side will crack about 25 degrees before the secondaries begin to open. We will be able to do exactly the same thing using the double throttle control of the third generation engine. We will have it, we will control it by a solenoid and a vacuum source, so that anytime that the engine is under vacuum, the secondary throttle will close. It'll be the same thing as having the throttle body closed. Depending on the boost level that we set on the ECU or through an external hop switch, we'll have a Greddy, an intake, an elbow like this, just like a Greddy, put on the actual third generation intake manifold, and regardless of throttle opening of the fly-by-wire throttle body, which will essentially go where the normal charge line would go on a third generation, it will go right here. Okay, regardless of the throttle opening of the fly-by-wire throttle body, all of the incoming air will go through the primary port. Under certain boost conditions and under certain mappable conditions, trailing throttle, this and that, we will be able to slam the secondary side of the motor open, or open it very gradually, just like you would with the third generation throttle body. You can either open it gradually or you can slam it open. Either way, we'll be able to do that with the ECU, and it's a very simple system. It's something that I've been doing for many, many years on third generation engines, keeping the secondary double throttle control system closed until about 6 or 7 pounds of boost, creating more torque, because you're actually feeding boost to your primary side, maintaining your air velocity very high and giving the engine more torque to work with before you open the secondary side of the engine. So this is already a proven system, something we've been doing for at least 15-20 years. Now we'll be able to do it with a fly-by-wire throttle body, which will be sitting out here in front of this elbow. Very simple system.
Planning on including that in the kits, or?
Yes. The kit will include everything you will need to basically get yourself either a JDM engine block, or a built-up third gen block, or a second gen block for that matter, an FC block. But it will require, the whole system will be based on the third gen upper intake manifold, which has the double throttle control built into the manifold. Without this, all 4 ports would be open and the engine would be very lazy, because the intake air charge velocity will be quite low until you get into your very high RPMs. That is the reason why the throttle body on every RX-7, beginning from the 85 GS LSC, is a progressive design. Primary, then secondary. The reason behind that is to keep the air velocity high. You want to keep the air velocity at about 300 feet per second. That induces torque very rapidly. If all the ports in the engine are wide open, as in a racing engine, there's very little power until you get up to 7,000 RPM and above. On a street engine, you need to have torque, you need to have instant throttle response. So that is the reason why you must have a primary and a secondary side. That is why the system has to work with the third generation intake manifold, because it is the only one that has an integrated double throttle system, and we will control this throttle bottle system through a vacuum source, a solenoid, and a bleed orifice to allow it to either open very gradually or slam it open depending on throttle opening of the fly-by-wire.
So it's like mechanically controlled rather than computer controlled?
It will be computer controlled. Mechanically controlled would be if you had a throttle cable opening your throttle valves. This would be mechanically controlled. Electronically controlled is when regardless of your throttle input, the servo motor on the fly-by-wire throttle body opens and closes the throttle valve at a rate where the engine can take the airflow. If it opens it too fast, then the air velocity drops and the engine falls flat on its face. That is the reason why all the cars that are fly-by-wire and all the manufacturers that are going to fly-by-wire is because they can run a much larger throttle body, therefore increasing the point, the RPM choke point of the throttle valve. So again, having the secondary throttle control, double throttle control closed, regardless of throttle opening, the amount of air that's going to go through the primary port is fixed. Once that air velocity reaches 300 feet per second, it is not going to flow anymore. So regardless of throttle opening, as long as you're on the primary side and the secondaries are closed, the car's going to have absolutely smooth and linear acceleration. Then at the point where we want it to open, and that will be very easy to do, mappable. It'll either be, you can do it mappable, or you can do it through a hop switch, or you can do it through a combination of both. Depending on the boost or RPM that we wish to bring the double throttle control open, we can either slam it open or we can bring it in gradually, just like if you were accelerating gradually on the highway. Absolutely beautiful integration of electronics and what is available to work with.
What's your time frame to get one of these up and running, do you think?
Well, right now we're in the midst of finishing up a very large project in Europe. That's probably going to take the better half of the next month, maybe a month and a half. We do have a hang-up in parts delivery. If they come in time, then we go forward with it. At the earliest, it's going. What are we in July now? July, October, September, and beginning of September, actually end of September, we'll be working on the. We'll have a running project. If the parts don't show up in time, and we have to shift time around, then I would stick my head on the chopping block if we don't have it ready by end of July.
Thank you.